All right, thanks for joining me. Let's go ahead and take a look at a little bit of AROC, IROC in the more powerful version. If you want to call it the sledgehammer, that would be appropriate. So remember what we are dealing with when we deal with AROC, that is the average rate of change between two values. This is actually known as a secant line. And remember what we're doing is we're actually finding that slope, not necessarily the line, but the slope of that line, that secant line. And that would be y2 minus y1 all over x2 minus x1, but x plus h minus x would just be h. Now that AROC would actually give you the average for every value of x. So this x could be any number that I want. And x plus h is just some displacement from that number. So I could literally do any values that I want, and I'll try to demonstrate that in a minute. And then if we do IROC, which is instantaneous rate of change, we have a special notation for that. That's called f prime. That's kind of the way that we would say that. And that would be the limit as that h value goes to 0. Now, if we want that h value to go to 0, then effectively we're saying, you know what, let's go from this point and let's barely move at all. And if we barely move at all and we suck those two values together, we're going to be looking at something like this, which is going to be called a tangent line. So give me 1 second. Let me check that phone situation. All right, so I'm back. Sorry about that. So again, back to what we were doing here. We were looking at the fact that once you add that limit to it, it becomes the equation of what we call a tangent line, where it literally just hits in precisely that one place, okay? So keep in mind, we're taking this value right here and we're getting it closer and closer and closer until they actually touch. So we have to kind of go through the process a little bit slowly. So the first thing that we do is we're going to do f of x plus h minus f of x all over h. And I will tell you, this is something that I kind of did struggle with when I was in high school, is that you're going to take f of x, which is 4x squared minus 7x plus 1. And all of this stuff is f of x plus h. So everywhere where we had an x, we're going to replace that thing with x plus h. All of this is that f of x plus h. That looks horrible. It really does. But then it says, let's take away f of x itself, which is right here. So f of x itself, that's kind of gross. There's a lot to write there, all over h. Now, again, first line of this looks horrible. Notice I didn't bother to do the limit. I'm just doing AROC for a minute because I'm just going to try to make the writing a little bit simpler, the average rate of change. So remember, if you take x plus h and you square it, that's x plus h times x plus h. And the distributive property is going to give you an x squared. We're going to get an xh and another xh. So you got two xh's and an h squared. Now, that's the portion of that thing that if you kind of watch it, this is the portion that a lot of students miss. They miss that particular piece of it, and keep your eyes on that later on, because as it turns out, that's the one portion of this graph that's going to become the significant one. So ultimately, you make that tiny careless mistake that people go, well, no big deal. It's not that big of a deal. It's a very big deal. So here we go. So I have 4 of those x squared plus 2xh's plus h squared that I mentioned a minute ago. I've got minus 7x minus 7h plus 1. And I'm going to go ahead and distribute this negative through. And that was a minus 1 then, all over h. Now, for what it's worth, we now can go in here like a shooting gallery and start plinking things off. And you're going to notice that negative 1 and the positive 1, the negative 7x, the positive x, the 4x squared, the negative 4x squared. Everybody that doesn't have an h seems to have disappeared. And what you're going to notice is the pieces that are left are here, here, and here. Those are the only pieces that are left. So what I have is 8xh, but I'm going to divide that by h. So I'm going to get 8x. I'm going to have 4h squared, so that's going to be 4h minus 7. So out of all of that stuff, this is my average rate of change, which means my f prime of x, which is the limit as h goes to 0 of this value, is just going to be 4x minus 7. Now, I wanted to have both of these here for a moment because I wanted to kind of just make sure that I've landed that plane. Well, that if I said I wanted to find the slope of the secant, and let's say I wanted to find the slope of the secant from, let's say, x equals 3 to x equals, say, 5, then what I would be doing is I would be calling x3 and I would be calling h2, since by definition, h is that movement that I did. And so if I wanted to find the slope from 3 to 5, I can literally plug that in, and 8 times 3 plus 4 times 2, we said h was 2, minus 7. And so I've got 24 plus 6 is 30. 30 minus 7 is 23. And I would find that that average rate of change in that was what we have. And that would literally find any value. But see here, I could say, what is f prime of, let's say, 2? And that would be 8 times 2 minus 7, which is 16 minus 7, or 9. And that means that on this particular graph that I've got this parabola like this. And it means that if I came over here and I found the location 2 comma whatever f of 2 is, that would be 16 minus 14 is 2 plus 1 is 3. At 2 comma 3, the slope of this line right here would be a steepness level of 9 at that tangent value. Okay. So that's kind of how it works. So if you don't put that limit on it, you get all of these slopes that are revolving around any 2 points that you pick. But once you put that limit on it, it's a very powerful thing because it then allows you to find that instantaneous rate of change everywhere. So moving to this next one, if we wanted to find f of x plus h, we're going to replace x by x plus h. So remember, this was g of x plus h minus g of x all over h. And I understand that when we look at this problem, it looks like it's going to be absolutely horrifying. But remember, the trick that we learned was that anytime you're trying to simplify a crazy radical type story, we want to go ahead and use that conjugate. So I'm going to multiply the numerator by exactly what it said with a switch in the middle. All over again, I have to be fair and do the same thing top and bottom. And the nice thing is although it looks like it's going to be horrifying, it actually comes out pretty nice. So my denominator has my root. But my numerator is going to have some big stuff going on. I should put a parentheses around all of that. So I get 4 x plus h's plus 3's. That's this portion. My outer and my inner would cancel, and then I have a loss of a 4x plus 3, because the root 4x plus 3 times the root 4x plus 3 is going to be that. Now, as we promised, what's going to happen is that original value that produced that 0 in the denominator has to go away. So this h is what's going to cause that problem. So what we're going to see is, the positive 3 here is going to cancel the negative 3 here. The negative 4x is going to cancel the positive 4x, and all we have left is 4h on top. So keep in mind that 4h and this h are going to cancel. So my average rate of change is going to be 4 over all of this stuff in the denominator. Now again, this is the slope of that secant line. Sorry, I ran out of room to write that. It's this thing, I just wrote it here and I just ran out of room. So if I did the limit as h goes to 0 of my AROC equation, I'm just going to go like that. It's that limit of that whole thing as h goes to 0. Well, the number 4 is still the number 4. And as h goes to 0, I got root 4x plus 3. And this is also going to be 4x plus 3 in a root. So what I got is 4 over 2 of those root 4x plus 3's, or in other words, 2 over roots of 4x plus 3, because I can simplify. This is what we would call f prime of x. And that would be the slope anywhere and everywhere on the curve. And what's interesting, if you really think about what is happening, you guys should know that a square root looks sort of like that, right? So interestingly enough, as x gets bigger, you can see that it gets less and less of a slope. Well, look right here, as x grows, the denominator is growing, therefore the slope is going to actually get less and less. As you go further, it's always a positive slope, but it's a positive slope that becomes less and less positive. So it's an increasing graph, but it's increasing at a decreasing rate. So there's a little something going on there. It's an increasing function, but the slope gets less and less, it's decreasing. Okay, that's one of the hard ones. And then the last, what I would argue is a difficult one, is when we have a rational equation. So if we're going to go straight to j prime of x, we're going to do the limit as h goes to 0. And so we're going to do j of x plus h right here. We're going to subtract j of x right here, all over h. But the fun part is we have to write x plus h minus 7 to x plus h plus 1's, right? And that does not look very fun because we've got some pretty nasty fractions and we got some pretty ugly things. And although these two denominators look similar, remember when we add fractions, you have to have perfectly identical denominators. Come on in, let's go. Okay, that's fine. All right, so what I'm going to do is I'm going to multiply the numerator by both a 2x plus h plus 1's. And I'm also going to multiply by a 2x plus 1. I'm going to do that to the top and the bottom, because we have to be fair. Now, again, this looks horrifying, but the good news is it actually comes out fairly decent. So let's do j prime. It is still the limit, but part of the whole thing is that this portion right here would cancel all of this right here. This portion is going to cancel all of that. And so what we have is we have our 3x plus 3h minus 7 that is being multiplied by 2x plus 1. Uh-oh, this is looking bad. And then this portion is going to cancel this portion. So now I have my 3x minus 7 being multiplied by a 2x plus 2h plus 1. All over h times 2x plus h plus 1 and 2x plus 1. Now, for very good reasons, when people look at a problem like this, they kind of get a little bit queasy in the stomach because this just does not look like this problem is getting better. In fact, I have to do a big distributive. I got to take this trinomial times this binomial. I need to take this binomial times this trinomial. This doesn't look like it's getting better. In fact, it looks like it just got worse and worse and worse. So what the heck? But I guess we'll have to just trust the process. I've got 6x squared plus 3x. I've got 6xh plus 3h. I've got minus 14x and a minus 7. Whew, there was a lot there. Then I come over to here, and I'm going to have a negative 6x squared. So I'm going to multiply these out, but I'm going to distribute this negative as I go. So I got 6x squared with a negative. I got a 6xh with a negative. I've got a 3x with a negative. Running out of room. I got negative 14x with a negative, so that's positive 14x. I got negative 14h, so positive 14h. Negative 7, so a positive 7. And all of that is over all of this mess. And you might be like, well, why aren't you distributing it? Well, because I've done enough. That I know that the denominator is what I call collateral damage. I'm leaving it alone. I'm not going to touch that thing. I'm just hoping for good things to happen. But now we've done all this super hard work, and now we get to go plink things away. And what I notice is the 6x squared here cancels the 6x squared here. The 3x here cancels with the 3x here. The 14x here cancels with the 14x there. The 7 here cancels with the 7 there. And hallelujah, check that out. The 6xh and the negative. In this case, even some of those went away. That's really cool. So out of that entire numerator, out of all of that stuff, crazy enough, I have a 3h and a 14h, and that's literally all that there's left. So that entire numerator came down to, just making sure that I am right on that, yeah, 14h, so 17h. Interesting. So all of that came down to just 17, all of that stuff, that's it. But our h's canceled. So as h goes to 0, we're going to cancel these two things out. And fun. As h goes to 0, then this portion is 2x plus 1. This portion is also 2x plus 1, and I got 2x plus 1 squared. Isn't that crazy how it goes from this really horrifying looking beast to something that is relatively small, and then boom, we're done. And that is the instantaneous rate of change on a polynomial. Be very, very careful about distributing those things correctly. On a radical, using the conjugate trick, or on a rational equation using a fraction buster. So those are the three big ones that we study, at least for the time being. Hey, thanks for joining me. I'll see you back in class. Have a good one. Bye-bye.